Hello student, welcome our channel The Physics Point. And in these lectures we are just discuss this is the fourth lectures about the general science and the first part of the general science, that is the physics. The definitions of the physics I will recall just only definition of the physics. The physics, it is the branch of science which deals with the study of matter, energy and relationship between the matters and energy. And today's lectures we are discussing the most important chapters and most famous chapter, or the most famous scientist in the in the particular lecture or in this lecture. This chapter is gravitations. Gravitations. Whenever we are listen the particular name or particular concept or the particular word gravitations, then we think about the only one scientist. The name of that particular scientist is Sir Isaac Newton. Because we are listening all about the story, all that types of the story about the gravitations. A man which are seated below the tree or below the apple tree, apple was dropped on the head of that particular man's or on the head of that scientist, and then these scientists discovered the laws, or these scientists which are discovered the gravitations or force of gravitations. But this is not true, or this is the partially truth about the talking. The story will be correct, but not still now, or not the about whole information. This story are not gives the whole informations about the laws or about the concept of gravitations. The 1,000 years below, or the 1,000 years ago, about the about the apple was dropped on the head of the Sir Isaac Newton, one of the Indian famous mathematician, famous scientist, which are said or write or gives the information in detail about the motion of that particular planets. The motion of the scientist is Aryabhatta. Aryabhatta is the scientist which are gives the whole information or detailed information about the motion of the planets around the sun or around the particular stars. Then these scientists will be write the all detailed informations in that in their book. The book will be Aryabhattiya. Aryabhattiya. This is the famous book, and the scientist is written or gives the all informations, all detailed informations of the motion planets. The gravitation, it is the force which are related to the planets. Each and every planets have the certain force which has or which is applied on the particular object which are living on that particular planets. These all forces are pull the all each and every object which are situated on or lies on the particular planets. The gravitation, it is the force or it is the concept which is related to the planets. Then after 5,000 years, this is the 5,000 AD. This will be all things are was happened in the 5,000 AD. The Aryabhatta which are gives the detailed information about the motions of the particular planets. Then, after 5,000 years, after Aryabhat's concept, 5,000 years of this particular concept, the name, the scientists which are gives the formulation about the motions of the planets, and the name of that scientist is Johann Kepler. The name of the scientist is Kepler, and the Kepler's three laws of planetary motions, which are discussed up to the 10th standard physics or 10th standard to the high level education of the physics. Kepler. The Kepler just gives the formulation about the planetary motions, and then he will be gives the three laws about the planetary motions of the planets or the motion, planetary motion of that planet. Then the first law, Kepler's first law. Kepler's which gives all about the three laws. Kepler's first law. the each and every planets revolving around the sun, each and every planets is revolving around the sun in elliptical orbit. That is, every planet revolving around sun in elliptical orbit, in elliptical orbit. And sun is situated at one focus, or the ellipse have the two focus or two centers. Consider this is a ellipse, this is the ellipse. When we are try to force this bulged area of the ellipse, then he make a circle, and the center like here and here, these are the focus of that particular ellipse. Ellipse has the two centers or two focus. When we are trying to force, push or apply certain pressures on the bulged shape of the particular ellipse, then he make a circle, and these two focus or these two centers try to comes together and meet at certain points, and it has collides on each other or coincident on each other, then circle have only one center, or the circle are pulled up, the circles having the pulled opposite direction, then make a ellipse. What is the first law? Every planet is revolving around the sun in the elliptical orbit. This is the consider a sun. This is the sun. Then every planet, this is consider this is the planet or this is the earth. Then each and every planet is revolving around the sun in elliptical orbit, or the path of the revolutions of that particular planets around the sun is elliptical, and sun is exactly situated at the one of the center, one of the focus of that particular ellipse. This is all about the first law or Kepler's first law. Then second law, Kepler's second law. When I was trying to join the line, or I will be draw a line which is joining between the center of the ellipse to the orbit, or planet to that particular sun. This is known as the radius vectors. Then the radius vectors is swept. Radius vector sweeps equal area in equal interval of time. Equal area and equal interval of time. When the planets is moving like this, and the planets is comes at the pointer A to the point B, and I will be drawn both radius from the both point of the planets, then it is like a triangle, and these areas or the radius vectors or the planets comes from the point A to the point B, which is taken a time t1, which has taken time t1. But when a planet at the point C, this is the point C, and this is the point D, which are moving from the point C to the point D, is taken equal time, but the area, both shaded area is equal areas. What about the laws? The radius vectors which are formed between the planets to the particular suns, the radius vector sweeps equal area in equal interval of time. म्हणजे जे काही हा एरिया आहे, दिस इज द एरिया, both shaded area is equal, and they are time taken from moving of that particular planets point A to the point B and point C to the point D is equal. But the length between the point A to the point B is less than the length between the point C to the D. Then we got one of the conclusion: when the planets is near to the sun, when the planets is near to the sun, then the motion of the planets or the velocity of the planets is much more greater than the planets is situated farther than the sun. What about, we will tell again, when the planets is near to the sun, then the motions of the planets or the velocity of the planets is much more greater than the planets when they are farther from the sun. This is the important concept, or this is the important conclusion from the Kepler's second law. What is the Kepler second law? Radius vector sweeps equal area in equal interval of time. This is the shortest, simplest, and easiest definitions or easiest law. Kepler's second law. First law: every planet is revolving around the sun in an elliptical orbit. This is the most uh, highlighted word, in the elliptical orbit, and sun is situated at one focus of that ellipse. And the both highlighted points from the first law is elliptical orbit as well as sun is situated at one foci. Then another one, second law, is the radius vector sweeps. The radius vector sweeps equal area and equal interval of time. Equal area in equal interval of time. It means the velocity of planet is greater when planet is near to the sun than the planet is farther from the sun. From the sun. The velocity of the planet is greater when the planet is near to the sun than the velocity of the planets which are farther from the sun. This is the most important conclusion, most important point which will be asked in MCQ, or on 1 mark, single mark, in any type of the examinations. Then new third law, Kepler's third law of planetary motions. He was formulated three laws about the motions of the planets or the planetary motions. First law is gives all informations about the orbits of that particular planets. This is known as orbital laws. And second is the aerial laws, which are gives the informations about the area or swept by the radius vectors of that particular planets and sun. The radius vectors are joining a line which are joining between the sun, which are situated at the focus, and planets which are revolving around the sun in the elliptical orbits. And third law, the square of time period. What is about the time period? A time taken by the object which are complete one revolutions around the axis of rotations. I will tell again. A time period is the time taken by the object to complete one revolutions around the axis of rotation or around the center of that particular circle or particular object, shape of that object. Then consider a planet which are start to revolving from the point A and again to reach point B, C, D, and he reach again at the same point A. Then he complete one revolution. Then this time taken to complete the one revolution is as called, say, T. Then the square of time period, the square of time period, the square of time period of the planet is proportional to proportional to cube of semi-major axis. Semi-major axis. Cube of the semi-major axis, which is must be called, that is R, or sometimes called this is the A. What is the semi-major axis? In the second laws, I will call the radius vector. This is must be semi-major axis. Why these are both different? I will be also called in the second law. This is also semi-major axis, and this is also semi-major axis. Why it does not call the radius? Because the radius is the same at every point. A radius, a circle having the radius. This is the circle which is having the radius, and radius will be same at every place. But in the ellipse, which have the two centers, and the radius will be changes. The distance between A to the sun will be different, and distance between C or D to the sun will be different. These are continuously changes, and that's why we are called, this is the semi-major axis. The square of time period, that is T, will be directly proportional of the planets, will be directly proportional to the cube of semi-major axis, that is R. And the formulated this T square is directly proportional to R cube or A cube. Or this is the T square, is directly proportional to the A cube. They be talking one about the constant of proportionality. This is known as Kepler's constant. That is T square is equal to K into R cube. Then K is equal to T square upon R cube. T square upon R cube. This is the important equations which will be asked. These all three laws will be asked 3 to 4 marks in the board examinations, or which is ask certain MCQs, or ask certain numerical equations or numerical problems on these third law. Just to recall all these three laws and going to the next concept, that is which is related to the gravitations. The Kepler's first law, every planet is revolving around the sun in the elliptical orbit, and sun is situated at one of the focus of that particular ellipse, which will be properly seen in the diagram. Then the second law, the radius vector sweeps equal area and equal interval of time. When we have discussed the second law, Kepler's second law, then we got one of the conclusion. This conclusion is related to the velocity of that planet. The velocity of the planets is greater when the planets is near to the sun, and the velocity of the planets is less or smaller when the planets is farther than the sun. This is the first concept. Then third law, the square of time period. Time period, it means the time taken by the particular object which are complete the one revolutions. Whenever we watching the watch or the clock on the wall, the second hand is start from moving from the 12, then again he meet at the 12 or reach at the point 12, then he complete one revolution. The second hand taken 1 minute to complete his one revolution. It means the time period of the second hand is 1 minute. In the third law, the square of time period of the planet is proportional to the cube of semi-major axis. It is the cube of semi-major axis of the ellipse. Then the semi-major axis may be R or A. Then T square is proportional to R cube, or T square is proportional to A cube. Then we are use one of the constant of proportionality. This constant of proportionality is K, and this K is known as Kepler's constant. The Kepler's constant K is equal to T square upon R cube. This is the whole informations about the Kepler's planetary motions, and we have discussed all laws about the Kepler planetary motions. Now let's go talking about the Newton's law of gravitations. Newton's law of gravitations, which will be gives the raw informations in the previous lecture. Songs are must be important whenever we are teaching, whenever we are discussing, whenever we are studying, because it gives the freshness about the concept or about the person. Then let's start to the Newton's law of gravitation. Second is Newton's law of gravitation or universal law of gravitation. Newton's law of gravitation. I will tell in the previous lecture, the gravitation it is only attractive force, and these forces are acting between the two objects which having the masses. Consider the two objects. This is the object 1 having the mass m1, and this will be another one object that is having the mass m2. The object having the different masses may be on equal masses. The center of that masses or center of that object is be shown in the diagram. Then the distance between these two objects, center to center distance, this is r. And what will be give the Newton's law of gravitation? The force of attractions. It must be attractive force. The force of attraction. The force of attraction between two objects. Between two objects which having the mass m1. Two objects which having the mass m1 and m2 is directly proportional to the square to the product of their masses, products of their masses, and inversely proportional to proportional to the square of distance between them. Distance between these two objects or them. And we again tell the Newton's first law of gravitation. The force of attraction between the two objects which having the mass m1 and m2 is directly proportional to the product of their masses, that is m1 and m2, and inversely proportional to the square of distance between them. The distance will be center to center distance of that particular object. The distance is r, or sometimes we call it will be d. The distance to distance object is center to center distance is r. Then let's formulate the first this laws. That is, F is directly proportional to the product of their masses, that is m1 and m2, and inversely proportional. Inversely it means a denominator, reciprocal of that particular thing. Inversely proportional to the square of distance between them, and the center to center distance between these two objects will be r, and the square of the r, that is the r square. When we are formulated the all things of law which are in the proportion, we need the constant of proportionalities. We need the constant of proportionality Then the constant of proportionality in these equations, F is equal to caps G, capital M, small m divided by r square. Because we are dealing with the mass of the earth. The gravitation, this force is related, this force is about the force of attraction between the earth and any object. And the earth, the mass of the earth will be used the caps m, and the mass of any object is the small m. Then g, g is the universal gravitational constant. G is known as the universal gravitational constant. Then the separate value of the g, that is g, the value of g equal to 6.67 into 10 raised to minus 11, that is Newton meter square per kg square. Newton meter square per kg square. It is the unit of universal gravitational constant. This is the constant value which does not changes any places in on the earth. But whenever we are discussing about these laws, the mass of the object, first object, or two friends are situated together or seated together, the one having the mass 50 kg, another having the mass 70 kg, and the distance between these two persons will be very small, that is 1 meters. Then the force, the F is equal to m1 m2 upon r square, and z will be here. Why we are does not, why we are touches strongly, why we are attract or touches to each other? Because the force, the product of very larger value, F is equal to, it is m1 and m2, that is 50 and 60 kg, 50 to 60, that is 300 upon the unit will be 1, distance is unit, uh, then 1 square is 1. Why we are directly comes or touch to each other or bind to each other? Because this is all, this is the larger things, or this is the high value. But when we are multiply with the universal gravitational constant, it is the very less value, 10 raised to minus 11 times less value. That's why we doesn't attract to each other. The force of attractions is much more greater, or the, sorry, not a force of attraction, the range of force of attraction is much more greater than when we are going to 15th floor of the building and jumps from the 15th floors, then the earth will be attract us from the 15th floor, or the 1 2 up to the 10 kilometer from this earth surface. This is the formula I will written again here, that is the F is equal to G, capital M, small m upon r square. Capital M is the mass of the earth, caps G is the acceleration, caps G is the universal gravitational constant, r square is the distance between the object which having the small mass, small m, and the earth. Then we are treated one another thing, that is acceleration due to gravity. This is the chapter, or this is the lecture which for only basic things, or which are introducing all types of the things. Acceleration due to gravity. So acceleration due to gravity, and the acceleration due to gravity is denoted by the small g, which is denoted by this small g. And the value of the acceleration due to gravity is decreasing when we are moving upward direction from the surface of the earth, and on the surface of the earth will be larger value of the acceleration due to gravity, having the larger value of acceleration due to gravity. That's why let's formulate about that. We know that the Newton's second law of motions, F is equal to m into a. M is the mass of that object and a is the accelerations of that object. When we are dealing with the gravity and we are under the concept we have to consider this acceleration is acceleration due to gravity. That is F is equal to m into z. This is the equation number 2 and this is the equation number first. When we are carefully observe the equation 1 and 2, the left hand side of the both these equations will be same. The left hand side will be force of the both equations. It means the right hand side must be congruent to each other. Then mz is equal to z caps m small m upon r square. Then the similar term will be cancelled out, which are situated from the opposite side of the equality sign. That is mm will be cancelled. Then z is equal to caps z caps m upon r square. Then we know the value of universal gravitational constant. We know about the mass of the earth. This is the standard, doesn't changes, and the distance will be changes. Then acceleration due to gravity will be changes. Then the value of acceleration due to gravity g will be 9.8 meter per second square. Meter per second square is the unit of acceleration which on the surface of earth. That's why the acceleration due to gravity will be changes, because when we are moving from the earth surface to upward directions, earth surface to upward direction, then the distance between the particular object and the uh, earth will be increases. Then what about the force? Force is universally proportional to the square of distance between them. If the distance increases, the force will be decreases. If the distance increases, acceleration due to gravity will be also decreases. Okay, this is all about the gravitations. Let's recall the Newton's law of gravitations. The force of attraction between the two objects which having the mass m1 and m2 which having the different masses is directly proportional to the product of their masses and inversely proportional to the square of distance between them. And these forces is always acting along the line journey between these two objects. This force is always acting along the line journey between these two objects. Then the formulations of this law, force of attraction is directly proportional to the product of their masses, that is m1 and m2, and inversely proportional to the square of distance between them. If this distance between these two objects, center to center distance is r, then that is r square. F is equal to caps g small caps m upon m divided by r square. Then capital G is the universal gravitational constant which having the standard value which doesn't changes any place on the surface. That is 6.67 into 10 raised to minus 11 Newton meter square per kg square. How they are calculated these formulas, or how they are calculated this particular unit? When we are dealing with the z, the r will be multiplied with the f. Then z is equal to fr square. And the m, the caps m and small m are the masses which having the unit kg is multiplied with the g. When they are moving another sides, they are divided. That is caps m upon small m. Then we know that the unit of the force is Newton. That is Newton. Unit of the length, radius is the, or r is the distance. Distance having the unit is length, or meter. Distance is length, and this is the meter, and meter square. Meter square divided by m into m, twice time of the mass. That is unit of the standard unit of mass is kg square. When they are moving upward, this is the negative sign. The power will be negative. This is all about the laws of gravitation. Then we will discuss the acceleration due to gravity. The accelerations of the object when they are moving from the upward towards to the center of that particular circle, or center to that particular earth, or particular any planets. Then we are now dealing about the earth. The force is F into A. This is the Newton's second law of motion. Then we are dealing in the acceleration due to gravity. This is G. Taking all of these things. Okay, we are stop here, and in the next lectures we will discuss the satellites, natural satellites, and types of the satellites, and projection of satellites will be discussed up to the next lecture. Thank you.